Ladies and gentlemen, call your parents, call your teachers, call your siblings, call your friends. I am about to do the Lewis structure for SO2. The first thing I like to do for Lewis structures is count the number of valence electrons. Oxygen is in group 16, and each oxygen brings 6 electrons with it. There are 2 of them, so that contributes 12 electrons total. Sulphur is in the same column, or group, and so it also brings 6 valence electrons with it. In total, 6 and 6 and 6 give us 18 valence electrons. Now, some kids wonder which atoms go in the center. Often it is the atom with the lowest electronegativity. In this case, that is sulfur. The way that I think about it is which atom can make the highest number of bonds. Oxygen prefers 2 bonds. Sulfur can have anywhere from, I think, 2 up to 6. Sulfur can make more bonds. It goes in the center. So, there's my sulfur in the center. Here are my oxygens on the outer bits of my molecule. I like to connect them with bonds to start off. Those 2 bonds costed me 4 electrons. 1, 2, 3, 4 electrons already in my structure. I need 18 total. I like to fill my outer atoms next. 2, 4, remember that. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I stopped at 8 electrons per oxygen because of the octet rule. 1, 2, 3, 4, 5, 6, 7, 8 electrons around each oxygen, and it's full. It can't hold any more electrons. But I've only got 16 electrons here total, so I need to dump my other 2. After all, I do need 18 on the central sulfur. I'm almost done, but I have to make sure that all the other atoms satisfy the octet rule. This oxygen does. It has 8 electrons around it. This oxygen does. It has 8 electrons around it. Let's see if my sulfur has 8 electrons. 1, 2, 3, 4, 5, 6. That's not 8. That's only 6. I need 2 more. The method for getting that to happen is to take 2 electrons for one of the oxygens and creating a double bond so that those 2 electrons are shared. This sulfur now has 2, 4, 6 electrons in bonds, 2 lone pairs, 2 electrons in this lone pair. That gives 8 total, and this sulfur satisfies the octet rule. Now, I do want to point out that there are formal charges on these atoms. Well, this atom has a formal charge of 0. 6 valence electrons minus the 4 dots minus the 2 lines gives me a formal charge of 0. 6 valence electrons minus the 3 lines minus the 2 dots gives me a formal charge of positive 1 on my sulfur. And 6 valence electrons minus 6 dots minus 1 line gives a formal charge of negative 1 on this oxygen. There's no way around that. We've already satisfied the octet rule. We would be breaking the octet rule if we moved any more electrons around.